Okay. Let me begin with a word of prayer. Dearly Father, we thank you for this day. I thank you for these students. Just ask again that you'd bless our work today, help us to glorify you in what we do, and just help the students to resolve any issues that they found on the quiz, that they would be able to be prepared for the test next week, and just do their best, Lord, each one of them, Lord, for your glory. In your name I pray, Lord Jesus. Amen. So, we'll talk more about the quiz at the end of class. Let's start with lines. Let's talk about lines. Unless there's a question about something in particular. So I'll have more time for questions at the end too, but let's just talk about lines. Right, and this is of course in XY plane to be more precise, right? So if you want to draw a picture of it, you can, right? Here's your X, here's your Y. A line is, well, a line, right? I've only hit one student so far this semester. Not in the face. It wasn't bad. So this is a line. What's its equation? Y equals mx plus b is what you guys tend to think about, right? M is called the slope, right? B is called the y-intercept. Why is that? Because if you look at this graph, where it intercepts the y is the value b, right? And how do we figure out the slope? What's the slope? If you take 2 points on the line, right, like this point and this point, and you make a little triangle, like so, you can look at the change in x and the change in y, right? And m, the slope, is going to be the change in y over the change in x. If we label those 2 points something specific, let's say this point is x1, y1, and let's suppose that that point right there is x2, y2, then change in y over change in x you get from y2 minus y1 divided by x2 minus x1. Anyway, I'm keeping it safely away from the board where will make me write more things that no one here can see. Can you guys even see what I wrote over there? Or is this marker too far gone? You can see it? Okay. So this is the so-called slope, right? Now, this is for what? This is all for a, what are the other kind of lines you could have? Where this, when does this formula not work? What's the special case? Still a line, right? But what if the line looks like this? Right? It goes through, let's say, A here. If your line looks like that, what's the y-intercept? What's the y-intercept of this line here? Sorry. Ah! I thought I'd have an assist. Oh well. Sorry, I'll try to do better. Obviously I need practice. I'll get more practice as the semester goes on and the markers invariably wear out. Anyway, the equation of this is not y equals mx plus b, right? This is a vertical line. What's the equation of it? In this case, x equals to a, right? This is a vertical line. What's the slope? Slope. Some people would say it's infinity. Other people would say it's undefined, right? Vertical slope. See, because what happens is the change in y is whatever you want it to be, right? The change in x on this line, well, it doesn't ever change the x. It's just a, right? So you get division by 0 for the slope there. Are we good so far? Other forms? Other formulas? We can talk about y equals to y1 plus m times x minus x1. This is the so-called point slope formula. All right, point slope form. And the reason it's called the point slope form is because the point is x1, y1. The slope is m, right? This is the point slope formula for a line, right? What else is there? Standard. Oh yeah, the standard. Oh. Wow. Did you read the book?
No.
Did your homework? Oh, you took this class. Oh, okay. Yeah, I don't see anybody calling that the standard form for the line except for your book. Like, I don't know anybody. I mean, okay, it's.
Well, there's slope standard and then.
Slope standard. Yeah, I mean.
Standard's AX plus BX equals C.
AX plus BX, BY, right, equals to C. This is the quote-unquote standard form, at least according to your book. I will say, like what I just said, calling this the slope-intercept form, that's standard language. Point slope is standard. There's also a 2-point formula for the line. 2-point formula is like this. So the 2-point formula, all you do is you take the point slope formula and you put in the formula for the slope into the formula for the line. So it's like y1 plus y2 minus y1 over x2 minus x1 times x minus x1, right? And you're right. There's also an intercept form of a line, which I forget, but I have to derive. There's one that the formula for the line is written in terms of its x-intercept and y-intercept. All right. Let's work a few examples. I'll come back to intercept and derive it for you. But let's warm ourselves up here. So the reason I put all this on the board is that these are this is the standard things we need to know.
What's the name of the formula you said?
Oh, thank you. This is the 2-point formula. I mean, because what's the basic geometric idea is what? If you have 2 points, that defines a line, right? Is that always true? I give you 2 points, it defines a line? There's only one stupid case where that doesn't define a line. What is it? Here's your 2 points to define a line. Check it out. 1, 2, my second point, 1, 2. Find me the line. You're like, yeah, stupid. I mean, you have to have 2 distinct points to define a distinct line, right? If I give you the same point twice, it doesn't count. You're like, stop that. All right, anyway. So these are the standard formulas for a line. Slope-intercept, point slope, standard form, of course, and the 2-point formula for a line. Which one of these we want to use for a given problem depends on the problem, all right? Now, if I just ask you, find the equation of a line, like on the quiz, the last problem I said, find the equation of a line. I didn't tell you which format to use, did I? So any of the formats is correct in that context. Like I accept basically an infinite number of answers in that context. Now, if I said, find me the equation for the line, please leave your answer in slope-intercept form, then I would insist that you rewrite it as mx plus b, yeah? So that's why we need to have this discussion. There's one other theoretical tidbit I should share with you, which is, parallel versus perpendicular. How's that go? Basically the definition is this, right? Y equals, let's say, m1x plus b1, and y equals m2x plus b2 are, number 1, parallel if what? If m1 equals to m2, right? And number 2, they're perpendicular if m1 is equal to minus 1 over m2. which is, by the way, the same as saying m2 is equal to minus 1 over m1. Isn't that neat? So it doesn't matter which one is the negative reciprocal of the other. That's a symmetric relation with respect to 1 and 2. And we have symbols. So like I use the symbol like a pair of lines, slash slash, for parallel. And I use like a, well, let me just draw them. So parallel, come on. I'll abbreviate like this. Well, I can't fit it in there. So I use like this symbol for parallel. I use this symbol for perpendicular. All right. Now, my definition falls short a little bit because would you say, how about a vertical line? A vertical line is perpendicular to what line? What line? What's that? A what? A horizontal line, right? So these formulas break down for that, but that's just conceptual, right? A vertical line is perpendicular to a horizontal line. And how about a vertical line? It's parallel to what? Other vertical lines, right? Any two vertical lines are parallel. So if you want to extend these formulas to infinity, you could kind of do that. But all right, anyway, examples. So let's see here. I'll start us out real easy. Y equals 13 plus 2x. All right. What are the slope and what's the y-intercept? We have y-intercept is 13, right? The slope is 2. So that's like one of the first things you need to be able to identify. Hey, that's a line. There's its slope. There's its y-intercept, right? And there it is. Doesn't have to be complicated. Example 2. Find line through 3, 7, and minus 1, 8. And to be more clear, I really want us to find the equation of the line. All right? So how are you going to do this? Yep.
It's going to be like 8 minus 7 over negative 1 minus 3.
Okay, so you're thinking about this is point 1, right? And this over here is point 2. So you want to look at like y2 minus y1 over x2 minus x1. Why are we doing that? What are we calculating? So you're proposing we calculate the slope, right, of the line which connects these two. So we take so you said 8 minus 7, right, over minus 1 minus 3, which gives us what? 1 over minus 4. Now what's the equation of the line? So I can just write it down. Here it is. Y equals to 7 minus 1/4 x minus 3. What did I do? I used, what did I use? Point slope. Now, what's the slope-intercept form of the line? How would you find that? So like, by the way, this is a perfectly good answer already. Okay, but let's find point slope. Excuse me, find slope-intercept. I'll say it right eventually. What do you got to do? Just work it out, right? So we've got y. So I got 7 minus 1/4 x plus 3/4, right? So y is equal to, what's 7 plus 3/4? It's, I think it's 31 over 4, right? Yeah, 31 over 4 minus 1/4 times x. So there you go. That is the so-called slope-intercept, right? Can you graph it? How would we graph this? Let's graph it. There's various ways to do this, right? In this problem, the easiest way to do it, we started with 2 points, right? 3, 7, where is that? So I'm going to not do this quite to scale because of my, so I'm going to make this 8, I'm going to make this 4. Here's -1, here's 1, here's 2, here's 3. So let's see here, 3, 7 is roughly speaking on my scale about here-ish, right? And -1, 8, where's that? Here, up here, right? And so what's the line? You remember when you were a kid, you played the game, what was it called? Remember the connect the dots? It's just that, right? So if I had a ruler, I could do better, right? But roughly speaking, there you go. That's the graph of the line. It has a very small slope and it's negative, right? So generically speaking, what's the concept we should remember? We have 2 kinds of lines, right? Ignoring the vertical ones. We have lines that are doing what? They're increasing everywhere, right? We have lines that are increasing everywhere. They look like this, right? We have lines that are decreasing everywhere. They look like that. And then you got vertical lines, right? I suppose you also have what's in between these 2 cases? The horizontal line, right? But ignoring horizontal and vertical for a second, this is M is positive. This is M is negative, right? Either you have the line increasing or you have it decreasing. In example 2, we had M equals -1/4 because the line was decreasing, and it's decreasing kind of slowly as they go. If you guys have questions, just jump in, all right? Example, yep.
Could we have used -1 and 8 instead of the 3, 7 for
Ah, so your question is, why did I use 3, 7? Couldn't I have used -1, 8? How would that worked out? Let's choose a different adventure, right? So we could have done, you're like, why didn't you use this point? Then we would have had 8 -1/4 x minus a -1, which is what? +1, right? And how does that work out? This is 8 -1/4 x -1/4, and 8 -1/4 is 32/4 -1/4, which is 31/4. So lo and behold, 31/4 -1/4 x. So don't worry, math, unlike postmodernism, is consistent because it is based on a truth, not the truth as you define it. Yeah. So it doesn't matter whether we take this as our base point or that as our base point. It's the same line. In fact, if you think about it, for a given line, there are infinitely many points you could choose as your base point, right? Like, I'm calling the base point. In this point slope formula, I'm calling this thing here, I'm calling this the base point, because that's the point the formula is based on. It's my language, but oh, the more I look at that, the more it's not a line. Oh, it's horrible. Anyway, does that answer your question? So you can't go wrong. Well, you can, but you have to do something like switch the meaning of x and y, right? That'll mess you up. You know, another way to make a mistake when you're calculating slope, switch the meaning of 1 and 2, going from the denominator to the numerator. It's another popular mistake. But let me stop advertising popular mistakes and go on here. So I'd like for you not to make mistakes. Ow. I just made a mistake. I tried to somehow close my finger into the marker. Kind of hurt. All right, here's another one. Sometimes we're given the equation of a line in standard form, something like 3x minus 2y equals 42, right? Suppose you're given that. There's a bunch of questions you could be asked, right? What's the slope of the line? What's the y-intercept of the line, right? Can you give me a point on the line? So let's find a bunch of things here. Let's find slope. Part B, find y-intercept. C, find x-intercept. D, find a parallel line through, and you guys pick it. What point do you want to put the parallel line through? Give me any point. It's your chance. No one has a favorite point? 2 and 4. 2, 4? All right. E, find perpendicular line. I saw you had a favorite point. What was it?
1, 1.
1, 1? All right. That's counterproductive to my teaching, but okay. See, 1, 1 is a bad point because you can't tell the difference between x and y, right? It's like, you know, contrast of white on white or something. But I'll allow it. I did open the floor. All right. So how do you face this problem? Like, what do you do? I'm going to work it over here. Is it okay if I erase my hideous graph over here and work this problem over here? Oh, okay, you're panning. I'll do it here then. Let me get rid of this offensive top hat. I need to get a new spray bottle. This thing keeps leaking on me. All right. So can you guys tell me what I should do? How do I find, I mean, a couple of these questions we can answer all at once, right? If you think about it, we can solve part A and part B by just doing what? Solve for y, right? We need to solve for y. So solve 3x minus 2y equals to 42 for y. So to do that, isolate the y. We have 3x minus 42 equals to 2y. You know, just move everything with y to the one side or the other, and then divide. So this gives me y is 3x minus 42 over 2, which simplifies to 3/2 x minus 42 over 2, which is 21. So what have we done? We have now what? Y equals 3/2 x minus 21 is the what? The slope intercept. Slope intercept form, right? And so now you can read what, you know, m equals what? 3/2, right? So there's your slope. What's the y-intercept? The y-intercept here is minus 21, right? I'm just getting that from looking at the equation above. All right, so I can graph this thing also. I probably should have put a part F, which is to graph it, you know. That is something we want to be able to do, graph it. So I'll start working on that because that'll help me explain the other thing. Oh, all right, well, minus 21, I guess that's down here, right? And the slope of 3/2, how do you understand that? How do you understand slope of 3/2? That means that, you know, yeah, you go up 3, Maybe I should have made this my 21. There. Come on. I have trouble writing at this particular height. All right. So suppose this is 20, 40, 60. All right. So the way to think about, one of the ways you can think about graphing, right? If you have a point on the graph, we do, because if you know the y-intercept, you know a point, right? The y-intercept is basically here, right? Minus 21, which is roughly minus 20 on my graph. Okay. So now what do? I do rise over run, right? So I do 3 up and 2 over. So 3/2 is change in y over change in x, right? So I can do a change in y of 3 and a change in x of 2. People typically call this the rise. People typically call this the run. Rise over run, right? So I go 2 over, ka-chunk, ka-chunk. That takes me to here, basically, right? And then 2 up, 3 up. 1, 2, 3. So roughly speaking, my second point would be up there. So I do, 2 over, 3 up. It's a positive slope, so I know qualitatively it looks something like this, right? And here you go. So there's the graph. So I seem to have answered part F before now we got to go back and do what? C, D, and E, right? So how about C? Can you guys tell me how do we find the X? Part C here, right? How to find X-intercept. Can you guys tell me? Do the opposite of what we did for Y? I like that answer. That is a very non-traditional answer. You can solve for X, look at it, and switch the roles of, whatever's added there has to be the X-intercept. I mean, you're right. But I heard somebody else saying, we're looking for this point right here, right? That's the X-intercept. What's the equation of the X-axis? Do you know? What's the equation of the Y-axis? Let's start there. What's the equation of the Y-axis? It is x equals to 0. That's the equation of the y-axis, right? Handwriting gets worse and worse the further you get down here. X equal to 0 is the equation of the y-axis. The x-axis, the equation of the x-axis is in fact y equals to 0, right? So if you're looking for this point, one way you can think about it is you just take the equation and it's where y is equal to 0 and the equation is both true. So we have, y equals to 3/2 x minus 21, but y is also equal to what? 0. So you can just solve this equation to find the x-intercept. So we have 3/2 x equals to 21, which says x is equal to 2/3 of 21, which is, by the way, 14. So the x-intercept is 14. All right? Yep. I solve for x. I multiply by 2/3. It's like 2/3 is the natural enemy of 3/2, right? So that the 2/3 times 3/2 gives us 1, which leaves us x on the left-hand side. And then 2/3 times 21, well, 21 over 3 is 7. 7 times 2 is 14. So the x-intercept is 14, which in terms of a point, where is it? The x-intercept is where? To be fussy, it's at 14, comma 0, right? So the y-intercept was minus 21, which is where it's at 0, comma minus 21. I mean, we can, to be more precise, it's good to refer to the intercept by a point. but I don't, if I ask you what's the y-intercept and you give me the value of b, I'm not going to take points off, most likely. It would have to be a special context to take points off. All right, now, how about part D in part E? So that's the x-intercept. Any questions? How can we find a parallel line through 2, 4?
Solve for B, so use your points for
So we want m equal to what?
3 or 2.
3 over 2, right? Because it's the same slope, right? And what point do you want it to go through? 2, 4? 2, 4.
It's over here.
Oh, thank you. I forgot my statement.
4 equals 2 over 3 times 2 plus 2.
Yeah, y, you say y equals to, what was it, 4?
Well, because you used 4 as your, I mean, you do it different. I always just do it from slope first.
Oh, I am. So y equals my y and my 4 look too much alike. This is the number 4. So y equals the y component of the point plus the slope, which is 3/2, times x minus the 2. So this 4 is going there in the formula. This 2 is going there in the formula. And if I want to make this really messy, I'll draw an arrow for the slope. The slope is going here. That's the equation for the parallel line, right? Or if you want to write you could write y equals to what? 3/2 x. What's the y-intercept for this line? It's what? It's, if we have what? 4 minus 3, so plus 1. So there you go. There's the equation of the parallel line in the kind of usual standard form that you guys like, mx plus b. I'm personally at peace with point slope form for an answer.
Solve it and using the slope as your parent or intercept form. So like if
Intercept
I do
form.
it, I would have taken the 4 and said 4 equals 3 over 2 times 2 plus b and then solve for b.
Oh, so you want to make work. I mean, you can. So, see, my point to you is don't do that. So I mean, I got what you're doing, and this is often taught in the previous course, even in this course. Right, right. But why are we doing it that way? Think about it for a second. So y equals mx plus b, right? So you're like, okay, well, I'm going through 2, 4, which means I've got to set 4 is equal to 2 times m plus b, right? Right? And then you find b is equal to, and the m is what, 3/2, right? So 2 times 3/2, right? Fine. I'm trying to write it in the right order. 3/2 times 2, which is b equals to 1, right? My point to you is, if you just write this down, that's the answer. Like, everything I wrote up here, you don't even have to do. If I just say find the equation for the line, this is the answer right here. No further arithmetic required.
But if you did write the,
If you did this to get to that, I would not take off points. But I really want for everyone to learn. I really, really, really want you to learn the point slope, because it is labor saving. But anyway, so we do not disagree. I just,
no, I was just like,
I got you. So E, what's the answer to E then? What slope do we want for the perpendicular line? I'm probably where you guys can't see. Let me work this over here so everybody can see it. We have m equals to minus 1 over, what is it? Our given slope of the line we're trying to find a perpendicular line to, 3/2, right? So we need minus 1 over 3/2, which, by the way, is minus 2/3. So that's the slope we want, right? The point that I was given, the pedagogically unhelpful, 1 minus 2/3 x minus 1. So there's the equation of the perpendicular line through 1, 1. It's right there. Now, if we do it your way, we need to do y equals to, how's it go, minus 2/3 x plus b. So our point,
Do 1 equals 2/3 times 1, which is 2/3 times
so yeah, b, well, when I add,
b. And 5/3.
yeah. So therefore y equals to minus 2/3 x plus 5/3 would be the equation for the perpendicular line. Okay. And of course, you can get that formula, right? You can get this by just doing the math up here, right? So this is 1 minus a minus 2, which is 1 plus 2/3, which is 5/3, right? So we're never going to disagree as long as we both do correct mathematics, right? Now there's a danger in these problems, which is to get confused about which b you're talking about or about which m you're talking about. I just put down b here, right? Notice that this is not the same b as the b here, you know? So we got to be wary of the context. Sometimes when I'm working on more than one line, I start putting a 1 for the first one and a 2 for the second one just to make sure I keep things straight. But anyway, that's pretty much all I've got to tell you guys about lines. If you have questions about the homework, like, feel free to ask. Yeah. So like, I think there are 2 versions. If I remember right, I made 2 versions of the quiz. And I intended for one version to have the parallel question and one question to have the perpendicular question for the line. You know, so as you're studying for the test, you should know there are 2 versions to the quiz. They are different. They have different problems. There's some commonality, but there are some problems that are really quite different. You need to study both to be properly prepared for the test, all right?
How long is the test versus the quiz?
About the same. I may make it shorter. It kind of depends on what I see globally. If, as I grade the test, I've got 20% of the people who could do the test in time and were fine, then I know the test wasn't too long. But if there's only like 3 people from all 120 people I gave the test to that finished it on time, then I know it's too long. I can't judge until I grade everybody. Yeah.
Can you make it shorter than the quiz?
Probably.
Because honestly, like, I don't think that I had enough time for the quiz, so
I don't think so either. I started writing whatever I could and just circled the last thing I wrote down.
Like I said, once I have graded all the quizzes, then I'll make a determination, but it will likely be shorter. But now, here's a better question. Why was it too long? What did you get stuck on?
I don't think you had enough time.
I think it was just a lot of multi-step problems, and we were expecting to just have maybe the whole class period, and just because of the stuff we couldn't control, that it wouldn't get that enough time.
Yeah, but yeah, for you, so you guys got that pesky, yeah, that's right. You were a victim of the elevator. I should have just walked down those stairs. It's like, you idiot. It takes 2 minutes to walk down the stairs. I was just waiting for the elevator for 15. Dummy. Not me, not you, right? So that won't happen again. But yeah, I think the test is likely to be a little bit shorter, but still it's an important question. What took you the time?
I think it's just a lot of multi-step stuff, and a lot of inequalities and absolute values, and you guys need to split them and that sort of thing.
And a lot of us don't like work at the same pace. Like someone, it might take a little shorter to complete a problem, but for someone else it might take a little longer. And then I think having a short class period also didn't help at all.
Totally agreed. But the question remains, what took you too much time on the quiz? Like, what specific problem? Where was it? Like, was it that you didn't know what you were doing at the start of it? Are you sure that as you started every problem, like, this is greater than I do this, I work, or do you have to stop and think about it, you know?
For me, if I get stuck anywhere, if I don't exactly know what to do, I just move on, and I couldn't finish either. So I just did the ones that I could do, and I still didn't know them.
Okay. But, I mean, I'm probably making it shorter, but because it wasn't just you guys. Like, you guys are understandable because of what happened in here, but the other sections, even though they had another 10 minutes, they were still not, like, I had some people finish, but not a lot. So it's probably too long. But I mean, historically speaking, it's pretty comparable to the length of college algebra tests I've given before. So, you know, I don't think it's like crazy long or anything. Yeah.
Will we get the quizzes back before the test?
I am hoping to have the quiz graded to return back to you guys Monday. Let's talk a little bit about the quiz while we have a couple minutes, you know. So here's one that like a lot of you guys got stumped on. Now, I like your strategy of if you just don't know what to do, you move on. That's very healthy. You know, that's a good strategy for math tests, especially, you know. I mean, I remember once I was taking a test, and I was a double major in math and physics, and I remember sitting and staring at this test, and then all of a sudden I realized it'd been 15 minutes. I'd written nothing, but it's like a 50-minute test. I'm like, what am I doing? You know?
The thing is that in South Africa, you can't choose which math you want. Like, it's like, if you choose math, you do from everything.
Uh-huh.
And it was only divided into 2 tests. So we had like, I think it was 3-hour tests, but it was like, you had to do for 3 points, you had 1 minute for 3 points. And so the teacher always said, if you don't know, just move on. And most of us never got it finished.
So you were trained in your previous education. That is good. Not everyone has that background. So this one, a lot of you said can't factor, right? But it can. You just have to look at this as x squared minus the square root of 7 squared. And then it's just x minus root 7, x plus root 7, right? So that took me about 20 seconds to write down. Some of you probably spent 2 minutes on that problem. Yeah.
On the elected quizzes and stuff, would you just accept if we put x plus or minus the square root of 7?
Thank you. This is another question. I would not accept that. So the question was to factor. Factor. All right? That is different. And this is the other, now, now I'm talking to at least half of you. I said factor. What does factor mean? Factor means this. This is different than solve. There was no equals to 0 in that problem. You guys added the equals to 0 because you're more comfortable with that. And because this is like one of the fundamental confusions of the college algebra student. Factoring and solving. You take these two things and you meld them in your mind. You make them one thing, but they're two separate things. They inform each other, but they are different. Solve this, then yeah. I mean, there's 2 different ways you can do it. Use square root property, right? You can do this, and then square root property says x is plus or minus root 7. Great, right? But this is not factoring. This is solving a corresponding equation. It's a different problem you're solving. It's not the problem which was asked. Because I asked you to factor. This comment applies to like A, B, C, D, and E. Well, at least A, B, C, D. If you didn't get part E on number 1, that's totally understandable. That part E1, this one, most people got this wrong, and I am not surprised by that, and that's okay. It's not something I emphasized. You had some homework on it, but it's not something I emphasized. This one here, so this is one thing. So you guys are solving where you're supposed to be factoring. You know, that does make the problem. Well, anyway, so this one here, we have to do is we look at these first two, and well, I can factor x squared out. All right. And then I still have this, right? So I'm going to rewrite it suggestively like this. This is 1 times x plus 3. The reason I wrote that is so now you can see it. we have a common factor of x plus 3 here and here. So then we can use the distributive property and rewrite it like this. So the other very common mistake, one of the problems was x to the 4th minus 81. Let's talk about that one for a minute. So what I just did is called factoring by grouping, right? Listen, probably less than 5% of the class got this right. So if you got it wrong, don't feel bad. I mean, you're not alone. But this is something that you can fix, right? If I have a problem that looks like this, you probably should think about factoring by grouping. All right. This one here is x squared minus 9 times x squared plus 9. And that's not, I mean, so a lot of you, maybe half of you wrote that who took this version of the quiz. Great, that's wonderful, that's half of it. There's more, because you're asked to factor completely, right? So factor completely means you keep factoring until you can't factor anymore. This one factors. So, you know, I did give half credit for that. But listen, you know, the bigger thing, the reason I give you a quiz in here is to learn, right? Lots of mistakes were made, much opportunity for learning, right? And so hopefully you don't make that same mistake on the test. That's the whole point, yeah? Uh-huh.
For the bottom one, would that be accepted if it was x plus 3 and then the x squared plus 1 and like the second, if it was flipped?
Oh, the other way around?
Yeah.
This is equal to x plus 3. Oh, no, these are the same. It's commutative. Anyway, guys, thanks, guys. Yeah, I should have the quiz to turn back to you Monday. By the way, there's one error in the key right now.
See, I just had a bad day.